Alright, so we'll start with number 1. So we're going to zoom down. Something like that. Alright, so we have the distance from the point 761, 76, -1 to the xy plane. Okay, so for this kind of question, just think about the 3D grid. If we want to think about the distance from the xy plane, which would be this one, the kind of ground plane here, well, any point, the distance from it, if you're over here or over here, the distance from that plane would be this. And that distance is simply just however high you are in z. It's your z coordinate would be this distance. And even if you're below the grid down here, your z coordinate still is your distance from the xy plane. So we just need to grab the z coordinate, which is this one. So this question can vary. It can ask, like, what is the distance from the zx plane, for example, and the distance from the zx plane would be however far you are in y. It would be your y coordinate. So what you can remember is what you're looking for is it's the missing variable in whatever they say. So if we want to know the distance from the xy plane, that's your z distance. If you want to know your okay, and then the magnitude of that. So overall we are 1 away. Even if we're down 1, your distance, I guess your magnitude of that is 1. So we'll go on to number 2. Find the distance in exact form between the points P and the point Q. So find the distance between these 2 points. Okay, so for that we're just going to use the distance formula. So the distance formula is, it just comes from the Pythagorean theorem. So your distance between 2 points is going to be this side squared plus this side squared. This side is going to be, if we label this x1, y1, the comma, and label this x2, y2, this distance is going to be x2 minus x1, and this distance is y2 minus y1. So your distance squared equals x2 minus x1 squared plus y2 minus y1 squared. Then we'll square root both sides. So your distance is equal to this squared, or square rooted, I should say. And then this will extend into 3D. So we'll just add in for z coordinates, we'll go z2 minus z1 squared. So we'll just plug all this into a calculator. And we're going from, okay, it doesn't matter which you pick to be x1 and x2 as long as you keep it consistent for every variable. Okay, so I get 2 square root 17. I'm going to plug in all those numbers. Okay, find the center and radius of the sphere with this equation. Okay, this is pretty easy. You just have to think about, again, just think about the 2D version like we did for distance. For a sphere, if it's shifted, say, a little bit over here, 1, 1, then the equation of a sphere, or not a sphere, but a circle would be shifted to the right one, shifted to the right, or shifted up one, equals, and then the radius squared, would shift you right one, and then up one. So that extends to a sphere, extend to 3D. If we want to find the center, it's gonna be the flip of this one, the flip of this one, and then the flip of the z coordinate. So the center will be -2, -5, 5. And then the radius is this. This is r squared, so we want to take the square root, so the radius is 7. Okay, now we're going to build an equation given the center and the radius. So we'll just do like what we said in the last one. It's going to be this, but the flip of each coordinate. X -5 squared. Actually, this one's going to be y. Z plus 8 squared is equal to, with the radius of 6, we make this 36. We find the standard equation of the sphere that has the point, this as 1 point, and this as 1 point, as endpoints of a diameter. So example 4, they're telling us 1 point of the diameter, and they're also telling us the other point of the diameter, with the middle being the center. So we'll call this point P, we'll call this point Q. So we have to figure out the equation of this circle. So P is 1, -6, 5. Q is 6, 3, -2. Okay, so if we want the equation of the circle, we want to know the center and the radius. So to get the center, we'll probably want to do, we could do like the midpoint formula. If you want to find the point in the middle of a line, say this is 10 and this is 20, 10 plus, it's always this number plus this number divided by 2. You can see 10 plus 20 is 30. If you cut that in half, you get 15. So the midpoint here would be take the midpoint of the x coordinates, take the midpoint of the y coordinates, and then take the midpoints of the z coordinates, would give us our 3D sphere, or the center of our sphere. So I guess I'll note over here the midpoint for x, the midpoint for y, and the midpoint for z will just be x1 plus x2 over 2, y1 plus y2 over 2, and etc. Okay, so we'll start doing that then. And then we'll note that these will be the coordinates for our center. So I guess I'll start filling them in over here. We'll have mx, my, mz. Okay, so x1 plus x2 divided by 2. So it's going to be 7 over 2, which is 3.5. I can probably just do this in my head. Y's combined would be -3 over 2, so it's -1.5. And then the z's give us 3 over 2, so it's also positive 1.5. -3 plus 2, okay, yeah. Okay, so we have the center of the circle. How about the radius? What we could do is we could find the distance between, the radius is this distance, so we could find the distance between the center and Q, or the center and P. So we can just use the distance formula. So the distance formula, again, is x2 minus x1 squared, and then all of the other coordinates, and you add them together, so go dot dot dot. So we'll do this between C and R, we'll find the distance. Or C and Q. So I'll do Q minus C. So I'll do 6 minus, maybe I'll just note C. So we're going to do these minus each other. So 6 minus 3.5 is 2.5. So we 2.5 squared. Squared, so now we'll do 3 minus 1.5, so that'll be 4.5, so plus 4.5 squared. Negative 2 minus 1.5 is going to give us negative 3.5. Negative 3.5 squared. There we go. We'll take the square root of all that, so it's 155 over 4. So it's the square root of 155 over 4. Is equal to the radius. Okay, so we'll start entering this in. 3.5, negative 1.5, radius. Let's see if that's right. I'll go x minus 3.5, y plus 1.5, and z minus 1.5 equals the radius squared, so that square root will just go away. So get this. Okay. Alright, number 6. Finally some vector kind of stuff. Alright, given the points A and B, find the vector from A to B. Okay, let me do that. So, to form the vector AB from point A to the point B, it's always n minus initial, your terminal minus your start. So we're going to be doing, to form the vector AB, it's going to be B minus A. We're going to subtract the points. So I can just do this in here. Set up our vectors. We're going to do 1 minus 6, which is negative 5. We'll do negative 6 minus 2, so it's negative 6 minus 2. Negative 6 plus 2 is negative 4. 0 minus 2 is negative 2. So it's just terminal minus initial. Okay, we have a vector v, and it has an initial point this. Find the terminal point. Okay, so we've got to do just a little bit of algebra. So it has this initial point, and it's always terminal minus initial gives you your vector. So the terminal point we don't know. We'll call it x, y, z. We're going to subtract the initial point, which is negative 6, 1, negative 1, and then that spits out our vector 7, 4, negative 1. So we can just go by columns here. X minus minus 6 should equal 7. So x plus 6 should equal 7. Y minus 1 should equal 4. And then z plus 1 should equal negative 1. So we can just solve for x, y, and z. Subtract 6 for the x. So these will all just be super easy. Subtract 6 over, so x is equal to 1. Add 1 over, y is 5. Subtract 1 over, z is negative 2. So that needs to be the terminal point. Okay, now we're just doing some scalar multiplication. This stuff's easy. Probably just do it in my head, maybe. I guess I'll just start with the multiplication, then do it. So we'll do 3 times a, so it'll be 6, 15, negative 3. And we're going to add that to 2 times b, so it'll be -8, -2, -4. So when we add these, we get -2, 13, and -7. Okay, more of the same stuff. It's going to be -a plus b, so it'll be 4, 3, was it just I and k? A, I, K, and B is true. Okay, so A just has 0, I, J, K. Oh, there's no J, I, J, K. It's -4I plus 0J minus 3K. So it's 4I plus 0J again, plus 3K. And we're adding that to B, which is just minus 5I plus 4J minus 4K. Okay, so when you add those, you'll get -I, 4J, -1K. So it's -I plus 4J minus K. How does it want it? Okay, okay, it's giving it IJK, but it wants it in vector form. -1, 4, -1. Alright, we're going to find the magnitude of A. I think we did this in the first homework assignment. The magnitude is just the square root of the components squared. So it's going to be 4 squared plus 1 squared plus 3 squared. I made this -1 positive one because it doesn't matter. Any component, even if it's negative, when we square it, will be positive. So you can just put the absolute value here. So you get 16 plus 1 plus 9. So you get 10 plus 16, so you get the square root of 26. We're going to find the magnitude of this one, so again, that's just going to be the square root of 9 plus 4 plus 25. So that's 29 plus 9, which would be 38, square root of 38. Let A be this vector, find a unit vector. Okay, so to find a unit vector, the unit vector is denoted a hat. And to get a hat, you take the vector A, and you're going to divide it by the magnitude of A. So we're thinking about, you can think about it as scalar multiplying the vector A by 1 over your magnitude. So first find the magnitude of A, which would be 9 plus 9 plus 25 plus 16. So that's 18 plus 16, so that's 14 plus 20, 34. I think that's right. 26, but 25. Okay, that's right. Okay, so then all you have to do is take A, and then divide each component by your magnitude. Albeit it's the square root of 34. Just copy and paste this. So -4, this will be +3. Okay. Okay, find a vector parallel to this vector with the magnitude of that. So vectors are parallel, it means they're going in the same direction. So the unit vector is nice because it has a magnitude of 1. That's the definition of a unit vector. And it's nice because it contains the information of the direction, it contains all the direction of the vector you want. But it only has a magnitude of 1, and then you can rescale it to whatever size you want, and it'll be parallel to that other vector. So what I mean is we're going to take the vector u, which is some vector 5, -3. We're going to find its unit vector, which is this tiny one here, where its magnitude is only 1, and then we're going to multiply it by a desired magnitude, the desired magnitude being 8, so we're going to scale it up by 8. So I think we had a problem like this in the first homework assignment, I'm not sure. So let's do that. Let's find the unit vector of u. So that to find the unit vector of u, we're going to divide u by the magnitude. So find the magnitude of u, which is going to be 25 plus 9 is 36, which is 6, so the magnitude of u right now is 6. So we're going to divide each component of u by 6. So that's the unit vector. And now we'll rescale it up by 8 to get a vector that's parallel to this but has a magnitude of 8. So we'll go 8 times u hat is going to be 40 over 6, negative 24 over 6. So that's 8, no, what is that, 4, and that doesn't simplify clearly, so we'll just enter it in like this. 40 over 6, negative 24 over 6. There's one I and j. Oh, I got the magnitude term. Oh my god, 25 plus 9 is not 36. It would be plus 11. It is indeed 34, so the square root of 34 is what goes on the bottom here. Because it was almost 36, I wanted it to be. But we got the same top numbers, and then that fixes the bottom numbers. So 4 over the square root of 34 I minus, and we have negative, okay, plus negative 24, square root of 34. Okay, on to the next one. Find a vector v with an initial point this, and a terminal point this, then find the unit vector in the direction of v, and then enter it in IJK format. Okay, that's easy. So first we'll have to get v by doing called p and q. So the terminal point is negative 8, negative 6, negative 8. The initial point is negative 5, 1, 0. So we're going to subtract these. So this would be negative 8 plus 5, which would be negative 3. This would be negative 6 minus 1 is negative 7. Negative 3 minus 0 is negative 8. So here's our vector. I'm going to subtract a green here. And we should have to find the unit vector. So we're just going to divide all of these by the magnitude. So the magnitude is going to be 9 plus 49 plus 64. I'm just going to not do that one in my head. 64 plus 49 plus 9 is 122. So we're going to divide all these by 122, square root of 122. So that's the unit vector. So it's going to go negative 3, square root of 122. I. So we'll go this is negative 7, this is negative 8. Okay, this is, I see. There we go. Okay, that's all homework assignment. Alright, so that's 2.2 explained. That's not too bad. Alright, so on to 2.3 will be the next one. Alright, adios.